Hello and welcome to a new paper. It's a new paper. We have arrived at a new paper. This is the. I don't know if it's accurate to say. Let me just read what's on the memo cover. This is the NSC, National Senior Certificate Examinations. So, the Department of Basic Education's paper. Yeah. Paper 1 of May 2023. So, let us get into it. So question 1.2, solve for x and y simultaneously. So our first equation is an exponential one. We've got 3 to the power of x plus y is equal to 27. And straight away, I know that 27 is a power of 3. So if this is true, then x plus y must be equal to 3. Anyway, so that's just something that stands out for me from the jump. Then secondly, we've got x squared plus y squared is equal to 17. So this is a circle with radius square root 17. So that's just and centered on the origin. So that's just a fun fact that isn't really going to help us right now, but you know, wah. Right, so we've got a quadratic equation. Can we call it that? An equation where the highest power is 2 for both variables. Right, so typically how we go about solving these this kind of a system of simultaneous equations where you don't have linear equations for both is that you would usually have a linear equation which you can rearrange and then use to substitute into the quadratic one. So for example, if you had 3x is equal to 5y, right, then you could rewrite this equation to just have the x as the subject and then take this bit and replace the x with it so that this equation would just be in terms of y instead of being in terms of x and y. Anyway, so issue is that we currently have an exponential equation here, but hopefully you've spotted the key over here, right, is that we've said that 27 is equal to 3 to the 3, but we've also been told it's the same as 3 to the x plus y. And so therefore, it must follow that 3 is equal to x plus y. So now, we have our linear equation, right? So we can go about this question like we normally do, right? So we can say, okay, I'm going to rewrite this so that y is the subject. So I'm going to leave y by itself over here. So this equation becomes y is equal to 3 minus x. So that can become our little equation number 1. So you take that and you sub it into the second equation, which is that guy, right? So we're going to replace the y with 3 minus x, and we're told that that is equal to 17. So you've got x squared. Let's expand it, right? And then we've got 2x squared minus 6x, and I'm going to minus 17 from both sides, which leaves us with negative 8. Okay, so this is quite nice because I can see that there's a common factor of 2. So I'm going to divide by 2 on both sides. So that's going to give us x squared minus 3x minus 4 is equal to 0. And if we factorize that, it's a nice and quick one to factorize. Otherwise, you could use the quadratic formula. All right, so that gives us x is equal to 4 or x is equal to negative 1. And I mean, I absolutely love paper 1 because you can virtually triple check. Maybe double, maybe not triple. But you can double check your answers. Oh, and we're not done. So we know that x is equal to 4, x is equal to minus 1, but we don't know what y is. Okay, so we can go back to this equation to figure out the values for y. So let's do it. So therefore, y is equal to 3 minus 4, or y is equal to 3 minus 1, which is equal to positive 4. So your sets of solution is, okay, either x is equal to 4 and y is equal to negative 1, or x is equal to negative 1 and y is equal to 4. Right, so now we can go back to my whole little spiel about the nice thing about paper 1. The very nice thing about paper 1 is that you can check your answers. You can do a bit of a sanity check to see, did I make sense? Do I have grounds to believe that this answer of mine makes sense? Okay, so I'm just going to shrink things so that we can... Oh, what am I doing? Right. Almost there. Okay, so let's check our answers. Where do I put it? Okay, it might be best to just put this in the same view as the question. Okay, right. So let us check that all the solutions work for all the equations, right? So we've got 3 to the power of 4 plus negative 1, and that does give us 27, right? And then let's test the other solution. So 3 to the power of negative 1 plus 4 gives us 27 as well. So our two sets of solutions work for the first equation, which is good. Now let's test for the second equation. So we have got 4 squared plus negative 1 squared does in fact give us 17. And then negative 1 squared plus 4 squared also gives us 17. Perfecto. So yeah, again, as with a lot of the questions that we have come across, they're usually not difficult mathematically. Like once you it's just about figuring out that starting point. And so I think maybe what I should try to do at the end of each video is just kind of highlight like what was the trick, or at least the trick for me. And in this case, the trick was in seeing how to turn that exponential equation into a linear equation, right? And that's something we kind of know from solving exponential equations to begin with. Like when you have had equations like a to the power of x is equal to 32 to the power of 2x minus 1, right? What you always try to do is to rewrite it. First, you try to rewrite it with the same base. So that would be that. And then from there, once the bases are the same, you can just equate the exponents, right? So exactly the same principle over here, right? And it just helps to know the powers as well. I think that's a takeaway from this video is know thy powers. Try to learn the powers of 2, 3, 4, 5, maybe even 6. 2, I would say know from 2 to the power of 1 up until 2 to the power of 10. 3 to the power of 1 up until 3 to the power of 5 or 6. 4, I mean, you kind of know the powers of 4 if you know the powers of 2, so you kind of covered there. The powers of 5, I would say from 5 to the power of 1 until 5 to the power of 4, and the powers of 6 to the power of 1 until 6 to the power of 3. I would say knowing those, like just having those in your psyche, helps you to spot straight away in a problem like this, that, oh, x plus y must be equal to 3 because 27 is a power of 3. Anyway, let's wrap it up over there.